Watch a fully loaded 18-wheeler roll past you on the highway and look closely at the back end. Somewhere on that trailer, there's a set of wheels barely touching the road. Sometimes they're not touching it at all, hovering an inch above the asphalt, spinning in the air, carrying no weight, doing what looks like nothing. Pull up next to one at a red light, and it looks almost broken. A full set of tires, a full axle assembly, brakes, brackets, air lines, an entire mechanical system just dangling there, doing nothing while the truck rolls forward on the axles beside it. If you didn't know better, you'd assume something had failed. A busted suspension. A part that should be touching the ground and isn't. The obvious answer is that they're spares. Backups in case a tire blows. That's what most people assume, and it's not crazy. Trucks do carry spares, bolted underneath the trailer or standing upright behind the cab. But that's not what these wheels are for. These axles are fully functional, fully engineered, and they cost the trucking company thousands of dollars to install. Tens of thousands over the life of a fleet. And for long stretches of every single trip, their entire job is to touch nothing. That's strange enough to sit with for a second. A company spends real money on hardware, bolts it to a truck worth over $100,000, wires it into the truck's own onboard computer, and then, often, lifts it into the air on purpose, sometimes for hundreds of miles at a stretch. Here's what you'll understand by the end of this. Those wheels aren't wasted. They're doing some of the most important work on the entire vehicle. They're just doing it in a way you can't see, against an enemy you've probably never thought about. One buried under the road you're driving on right now. One that has quietly shaped almost every heavy truck built in the last 60 years. The first explanation people reach for is stability. More wheels, more contact patches, a truck that can't tip over as easily. There's truth buried in this. A wider wheelbase does resist rollover better than a narrow one, and engineers do think hard about center of gravity when they design anything this tall, this heavy, this capable of jackknifing at highway speed. But stability doesn't explain why an axle would need to lift completely off the ground. If those wheels were there purely for balance, you'd want them planted all the time, not floating in the air exactly when the truck is moving fastest and needs the most control. The second explanation is about weight capacity. More axles must mean the truck can carry more, right? This one's closer to true, but it still doesn't explain the lifting part. If the point were simply more wheels equals more weight allowed, the truck would keep every axle on the ground permanently and just haul as much as it's rated for. Every trip, every load. Instead, these axles come up and down mid-route. A truck might drive to a warehouse with every axle down and fully loaded, drop off half its cargo, and then lift an axle for the second half of the route, as if the truck itself is recalculating, in real time, how many wheels it actually needs. The third explanation, the one that sounds almost too simple to be right, is fuel economy. Truckers will tell you flatly that lifting an unused axle saves gas. And they're not wrong. This is the first real thread worth pulling on. Every wheel touching the road creates rolling resistance. Rubber compresses under weight, flexes, and releases. And that flex converts a small amount of forward momentum into heat every single revolution. Multiply that by thousands of revolutions per mile across a 50,000-mile year, and it becomes real money at the pump. Lift an axle that isn't carrying weight, and you cut that loss instantly. But fuel savings alone still don't explain why this system exists at this scale. Engineered this precisely, standardized across nearly every heavy-duty manufacturer, and regulated this specifically by law in ways that have nothing to do with a trucking company's fuel budget. If fuel were the only reason, you'd expect the technology to vary wildly from one manufacturer to another, a nice-to-have feature rather than a near-universal standard. Instead, it's remarkably consistent, built to the same underlying logic across almost every serious truck manufacturer on the planet. Something bigger is going on here, something that has almost nothing to do with what happens if a truck doesn't have these axles. and everything to do with what happens to the road underneath you if it didn't. Here's a claim that sounds impossible at first. Doubling the weight on a single axle doesn't do double the damage to the road beneath it. It does roughly 16 times the damage. This is called the fourth power law, and it comes out of research the American Association of State Highway Officials ran in the late 1950s, in a project now known as the AASHO Road Test. Just outside Ottawa, Illinois, engineers built several miles of real highway loop, in multiple configurations of thickness and material, and then drove convoys of real trucks over those roads in tight circles, day and night, for 2 straight years. They logged everything: cracking, rutting, the depth of every pothole, the exact axle weight of every truck that made every single pass. It remains one of the largest, most exhaustive road engineering experiments ever conducted. What they found reshaped how every country in the world regulates trucking. Road damage doesn't scale with weight. It scales with weight raised to roughly the fourth power. A car weighing 4,000 pounds on one axle does a tiny fraction of the damage a truck axle carrying 20,000 pounds does. Not 5 times less, but thousands of times less. Run the math, and a single loaded truck axle can do more damage to a road surface in one pass than 10,000 ordinary cars driving over that same stretch of pavement. Think of it like stepping on ice. One person's weight, spread across 2 feet, might not crack the surface at all. Now imagine the same total weight concentrated onto a single spike heel. Same mass, wildly different outcome. Because what matters isn't how heavy you are, it's how much force lands on any one point. Roads work the same way. It's not the truck's total weight that destroys pavement. It's how much of that weight presses down through each individual axle, at each individual moment. So if a truck needs to carry 80,000 pounds of cargo, legally and physically, engineers have exactly 2 options: concentrate that weight onto fewer axles and destroy the road exponentially faster, or spread it across more axles, and let the fourth power math work in reverse, cutting the damage per axle down to a survivable level. This is why heavy trucks have 5, 6, sometimes 9 axles instead of 2. It's not about carrying more weight. It's about carrying the same weight in a way that doesn't grind the highway system into gravel. Now here's the second layer, and it's where the lifting axles finally make sense. Federal and state weight laws don't just cap the total weight of a truck. They cap the weight per axle, and more specifically, per axle group, using something called the bridge formula, a sliding scale equation that sets a maximum weight based on how many axles a truck has and how far apart they're spaced. It was written specifically to protect bridges, which fail differently than open road. A bridge span concentrates stress across a fixed, relatively short structure, instead of distributing it across miles of continuous asphalt the way an open highway does. Get the math wrong on a bridge, and the failure isn't a pothole. It's structural. Picture 4 people carrying a heavy table across a room. If they're all bunched close together at one end, each person strains under an awkward, concentrated load, and the frame itself twists under the imbalance. Spread those same 4 people evenly under the table's corners and edges, and suddenly, the exact same table feels lighter to each individual carrier, and the frame stays level. The bridge formula, mathematically, is an incentive to spread out. A truck's legal weight limit literally goes up as its axles spread farther apart and multiply in number, because the load per person, per axle, per point of contact, drops in a predictable, calculable way, and regulators built the law directly around that curve. This is why an axle needs to lift, not just exist. When the truck is empty or lightly loaded, that extra axle isn't providing any of the fourth power protection the law was built around, because there's no dangerous concentrated weight to spread out in the first place. Keeping it planted on the road at that point does nothing but generate rolling resistance, burn fuel, and, this part surprises people, wear out a perfectly good set of tires for zero benefit, since a tire rolling under no load still wears against the road surface over enough miles. So the axle rises. It waits. Air suspension systems, controlled from a switch or an automated sensor in the cab, inflate a bag that physically lifts the axle assembly a few inches, disengaging it from the road entirely until the truck is loaded heavy enough that spreading the weight actually matters again, at which point the system drops it back down, automatically, before the truck ever gets near a scale. There's a third layer buried inside this, one most drivers never think about. Tire wear isn't just about mileage, it's about scrubbing. When a truck turns a corner, every axle has to travel a slightly different arc, and axles positioned far from the truck's turning center scrub sideways against the pavement instead of rolling cleanly through the turn. Some of these lift axles are specifically kept up during tight maneuvering, backing into a loading dock, taking a sharp exit ramp, purely because an unloaded axle scrubbing against pavement during a turn wears through thousands of dollars of rubber for nothing. Engineers didn't just build wheels to carry weight. They built a system that knows, moment to moment, exactly when carrying weight is worth the cost of touching the road at all. Once you see this, the entire shape of a highway trip changes. Every truck you pass at a weigh station isn't just being checked for total weight. It's being checked axle by axle, because a truck can be comfortably under its overall weight limit and still be violating the specific per-axle limits that protect the road surface and the bridges you drive over every day without a second thought. That bridge you barely notice crossing on your commute is still standing, in part, because of a law written from a road test conducted with instrumentation buried in Illinois asphalt almost 70 years ago, tested to failure on purpose so the rest of us would never have to find that failure point by accident. It also explains something that seems irrational until now: why a nearly empty truck sometimes looks like it's driving on fewer wheels than a full one, wheels tucked up and idle while the truck cruises along seemingly unaffected. It's not a malfunction, and it's not laziness on the part of the driver. It's the system working exactly as designed, actively deciding, load by load, exit by exit, which wheels have earned the right to touch the ground in that specific moment, and it reframes the economics of trucking entirely. Fuel savings from lifting an idle axle aren't a lucky side effect bolted on afterward. They're baked into the same design logic that keeps roads intact in the first place. The industry didn't stumble onto axle lifting as a clever, cost-cutting trick that happened to also help the pavement. It emerged directly out of physics that punishes concentrated force exponentially, and a legal system built specifically to force trucking companies to respect that math whether they wanted to or not. The fuel savings turned out to be a bonus the industry was happy to discover, riding on top of a rule that was never really about fuel at all. Even the timing of when an axle lifts tells a story, if you know what to look for. Watch a truck pull out of a warehouse lot and you can sometimes see the rear axle drop the instant it's loaded past a certain threshold, responding to a pressure sensor reading the actual weight sitting on the frame in real time. Watch that same truck after its last delivery of the day, and you'll often see the axle rise again on the way back to the depot, empty, no longer needing the extra support it needed hours earlier. The truck is quietly renegotiating its relationship with the road every single time its cargo changes. Here's the detail that reframes everything. The fourth power law doesn't just apply to trucks. It applies to your own car, your bike, even your footsteps. Every point of contact you make with a road surface is doing damage on that same exponential curve, just at a scale so small it disappears into the background noise of a road built to handle it. Heavy trucks aren't a special case of physics. They're just the only vehicles forced by law to prove, axle by axle, that they've respected a rule the rest of us break constantly and never notice, because our weight was never enough to matter in the first place. The road you drive on isn't just concrete and asphalt. It's the physical record of a compromise between commerce and decay, negotiated one axle at a time, 60 years ago, and quietly enforced every single day since, by a system of wheels engineered to know exactly when to disappear. If stories like this, the hidden systems running, Underneath the ordinary things you interact with every day are the kind of thing that keeps your brain turning long after the video ends. That's exactly what this channel exists for. Stick around. There's a lot more hiding in plain sight.